Hello, and welcome to today's lesson, which will be on surds. So, first of all, what is a surd? Well, a surd, quite simply, is just a number with a root sign in it. So, for example, square root of 2 is a surd, square root of 3 is a surd, square root of 4,536 is a surd. And today we're going to look at what we can do with surds, simplifying surds, and then continuing on to surds in fractions. So first of all, what do I mean when I say simplifying a surd? Well, some surds, like square root of 2 and square root of 3, cannot be simplified. They are in their simplest form, which means effectively that the number under the root has no square factors. But if we take a number like square root of 8, we can simplify that into 2 root 2. And I will explain why now. As we know, square root of some number n equals n to the half. And we know we've been looking at powers, we know our power rules, but one other rule that applies with powers, if we have a to the, let's call it n, a to the n times b to the n, that equals a times b all to the n. We can try that out if we have 2 squared times 3 squared. Obviously, we know that 2 squared equals 2 times 2 and 3 squared equals 3 times 3. And when multiplying that together, we can write that as 2 times 3 times 2 times 3, because multiplication is commutative, which means that the order in which you multiply the two things is the same, i.e. 2 times 3 is exactly the same as 3 times 2. This doesn't work for subtraction and division, but addition and multiplication are commutative. I'll write that down. Commutative, I apologise, my M's are horrible. Commutative basically means you can do A then B or B then A. It doesn't matter. So here we've got 2 times 3 times 2 times 3, which is obviously 2 times 3 squared, and 2 times 3 equals 6. If you want to check that out, 2 squared times 3 squared is 4 times 9, which is 36, and 6 squared is 36. And this works for whatever power. So it also means that if we have a to the half times b to the half, that equals a times b to the half. And this is where simplifying surds comes in. To simplify a surd, we want to basically factor out that a to the half. So if we have root of some number n that equals root of a times b. So n equals a times b. If we want to work out the square root of both, to assume a is a square number, we can write square root of n equals the square root of a times the square root of b. It's a really sloppy square root sign, I apologise. And then obviously if a is a square, then square root of n equals whatever the square root of a is, I'll call it c, times the square root of b. So if we go back to root 8, can write root 8 as root of 4 times 2, which then goes to square root of 4 times the square root of 2. And obviously the square root of 4, as we know, is just 2. So it equals 2 times root 2. Commonly, you will see this just written as a 2 with the root 2, with no multiplication sign in the middle. If you see that, no, it's just multiplication. So, your turn now. Simplify root 50, root 27, and the square root of, let's go with 288. Okay, again, feel free to pause the video if you need a bit more time to do this. But once you're done, so square root of 50 equals the square root of 25 times 2. So it's square root of 25 times the square root of 2, which equals 5 root 2. Square root of 27 equals the square root of 9 times 3, which is the square root of 9, times the square root of 3, which equals 3 root 3. And the square root of 288 equals the square root of 144 times 2, which equals the square root of 144 times the square root of 2, which equals 12 root 2. Now, let's look at root 288 again. You can just straight away take out the 144, but I could also write square root of 288 as the square root of 4 times 72. And then, again, we can write this as square root of 4 times square root of 72, which we know equals 2 root 72. But our 72 can be simplified down further to equal 2 of root, say 36 times 2, or you could do 4 times 18, 9 times 8, whatever, as long as you factor out a square. Root 36 times root 2 there, which is 2 times 6 times root 2. And then, because everything's being multiplied, we can just, it's 2 times 6 root 2, which is just 12 root 2. And this is another good point to note. If we have a times b root n, that should be an n, sorry, that is just going to equal a times b root n. Okay, now we can treat surds just like any other number, so we can do addition with surds, subtraction with surds. Generally, you're going to want to leave things as a surd because, for example, the square root of 2 is approximately 1.41, but it has an infinite decimal expansion, so you don't want to be working with the decimal. If you ever have root 2, leave it in surd form. But, I mean, we could do root 2 plus root 2, that just equals 2 root 2. We can do things like root 2 plus root 3, but there's no way of simplifying that. Some things you can do though, if you had, say, root 2 plus root 8, because root 8 equals 2 root 2, we've now got one lot of root 2 plus 2 lots of root 2, which equals 3 root 2. So let's give you a couple of examples. Root 2 plus root 18 and root 3 plus, let's see, root 3 plus root 40, no, that doesn't work, root 75, sorry. So once you've had time to do that, root 2 plus root 18, root 2 is just root 2, root 18 is root 9 times root 2, or 3 root 2, so the whole thing comes to 4 root 2. If you then wanted to put it back into a single surd without the 4 on the front, you could. You would square the 4 and then multiply the 2 by 4 squared, you would get root 32. To be clear, 4 times root 2 equals root of 4 squared times root 2, because square rooting is the inverse of squaring, so if you square root and square, you get what you start with, so we haven't changed the 4 at all, just the square root of 16 times the square root of 2, which we've then seen is the square root of 16 times 2. Going back to the other example, root 3 plus root 75, root 3 is just root 3, root 75 is root 25 times root 3, which is 5 root 3, so that whole thing just equals 6 root 3. Equally, we can multiply surds, as I've shown there. If we had something like root 2 times root 3, that just equals root of 2 times 3, which equals root 6. I won't ask you to do any, because that's just a simple exercise in multiplication. But what we can do is we can use surds in fractions as well. For example, you can have the fraction 1 over root 2, or something like root 3 over 4. Both are acceptable fractions because they use real numbers on the top and bottom, even if some of those real numbers are surds. Now, root 3 over 4 is fine. We're happy with that. We don't want to change it. But 1 over root 2, we don't like having surds in our denominator on the bottom of the fraction. Fortunately, we have a way of changing this. So, if I have 1 over root 2, we've already established we can't change the number. We still need the number to have the same value. But one of the ways we can change what a number looks like without changing its value is multiplying by 1. And we know that any number over itself is 1. So we could say multiply by root 2 over root 2. And that would equal, obviously, 1 times root 2 is just root 2. Root 2 times root 2, if you multiply it out, is just root 2 over root of 2 times 2, which is root 2 over root 4, but we know root 4 is just 4. And this is called rationalizing the denominator, because once we're done, we always get a rational number, i.e. a number without a surd, on the bottom. So you have a go. Rationalize 3 over root 6, 5 over root 7, and yeah, let's go with 7 over root 8. So again, feel free to pause the video if you need more time. But let's have a look. So 3 over root 6, we're going to multiply by root 6 over root 6, is going to get us 3 root 6 over 36. And then obviously if we want to simplify the fraction, we can not 36, over 6. I do apologise. But yes, we can factor out the 3 from the numerator and denominator, and that will just leave us with root 6 over 2. So in case you're not sure, that 6 comes from root 6 times root 6. The general rule, root n times root n equals n. It's fairly obvious. The square root is what number when squared equals n. If you then square that number, i.e. multiply it by itself, you're going to get n. Okay, 5 over root 7. You multiply that by root 7 over root 7 equals 5 root 7 over 7, and that can't be simplified. Now, 7 over root 8, multiply that by root 8 over root 8, and we're going to get 7 root 8 over 8. And you may look at that and think that can't be simplified, but in fact it can. As we know, root 8 equals 2 root 2. So 7 root 8 equals 14 root 2. So our fraction then becomes 14 root 2 over 8. We can factor a 2 out of the numerator and denominator to leave 7 root 2 over 4. Similarly, we could have actually done that at the start. 7 root 8 equals 7 over 2 root 2. And because the 2 is a rational and we're multiplying, we could just multiply by root 2 instead of root 8. Let's see if we do that. Multiplies by 2 root 2, I'll remove that equal sign because it's no longer an equals. Gets us 7 root 2 over 2 root 2 times root 2. Now if we consider 2 root 2 times root 2, there are two ways of doing this. We can we can either convert the 2 root 2 back into a root 8 and then multiply through as we've seen before, or we can just know that it's 2 times root 2 times root 2, and because multiplication is commutative, we can consider the surd multiplication first, which is just 2 times, obviously root 2 times root 2 is 2, which still equals, that's a terrible 4, but it does equal 4. As a general rule, whenever you're manipulating surds, you always want to simplify them first. Okay, that's it for this video, but my next video will go more into rationalizing the denominator. This is where you have something like 7 over 1 plus root 2. I'll show you how to do that. And yeah, until then, keep safe and try not to die.